everybody, my name is Claude and my partner name is Faraz, and today we would like to talk about one of the fluid property called viscosity. Viscosity is a measurement of fluid resistance to deformation. We will learn about viscosity through two experiments, the Thomas-Stormer experiment and the Brookfield experiment. However, to learn better about viscosity, we will have to address the issue by using one of the many fluid out there. And the fluid that we will use will be the STE theory motor oil at room temperature, and we will apply various rotation per minute. And based on those different experiments, we will be able to learn better about the viscosity of that fluid. Thank you.
My name is Rasham, and I'm going to explain mathematically what viscosity represents. Viscosity, mathematically, we use the symbol mu, and we say mu equals tau over dV dy, where tau represents the shear force, and shear force essentially is the amount of tangential force over a specific area, and dV over dy is what we call the velocity gradient. Essentially, it represents the change in velocity of a fluid at a specific vertical height, dy. During the lab, we analyzed two different viscometers. The first one being the Thomas-Stormer viscometer, and the second one being the Brookfield viscometer. But for the purpose of this video presentation, we're only going to discuss the Thomas-Stormer viscometer. The Thomas-Stormer viscometer uses mass and gravity to create a torque about a drum. As you can see over here in this graphic, this is the drum right here. This is the reservoir, which is filled with the motor oil. And here are the weights located right here. And what we did was we would release the weights with this brake and start a stopwatch, and we would measure how much time it would take for the drum to complete 100 revolutions. Because once the weight would start dropping, the drum would start rotating in the fluid.
So far, we have covered the definition of viscosity. We went through the different steps that we had to cover to run the Thomas-Stormer viscometer experiment. And I would like to point out that we use three different masses to run the Thomas-Stormer viscometer, the 25, the 50, and the 100 grams. And based on the different data gathered during that experiment, we were able to put together this table here. What we have here is that the first thing we did was to measure the temperature of the oil that we used for the experiment. And we found that temperature to be 30 degrees Celsius. And based on that value of temperature, we use this graph here to find the equivalent viscosity of the oil based on the temperature. The next thing that we did is we were able to gather the average time that it took each of those masses to cover 100 revolutions. And based on that, we use the calibration curve, which is this slide here. Okay, if you look at the right corner here, we have a graph, the calibration curve for 25 gram, 50 gram, and 100 gram. So, knowing already what the average second cover to make 100 revolutions was, we came here and we were able to find for each of those average time the equivalent viscosity. In conclusion, it was determined that viscosity is a property of liquid to resist flow. And based on the experiment that we used for this presentation, the Thomas-Stormer experiment, we have learned that as temperature increase, viscosity decrease. Also, we found that the increase in weight or decrease in time does not affect viscosity. And also, another thing that we found in this experiment was that, look here, is that although we have measured the ore temperature, and we found based on this graph here that the viscosity was 0.15 Newton second per meter square. When we looked at what we found, during the experiment, we realized that we were kind of close to the actual viscosity that was found using this graph here. The percentage error was 16 for the 25 gram, it was 16.66 for the 50 gram, it was 19.33 for the 100 gram. And when we did the average of those viscosity, we found a value that was close to this measure viscosity using this graph. Based on those different observations, we choose to assume that the Thomas Stormer viscometer gave us some accurate values.